The average annual cost of electricity used in retail buildings in the United States is $1.21 per square foot. For a box retail store, electricity costs can exceed $250,000 per year. In many climates, air conditioning accounts for 25 to 50% of these costs, largely because the need for cooling coincides with peak electrical demand when electricity costs may be at a premium. Although newer variable speed air conditioners can reduce annual electricity consumption by 50%, they do not provide much savings during peak electrical demand. This is because the hotter it gets outside, the harder the air conditioner's compressor has to work to cool the air. Once the temperature gets high enough, even high-efficiency vapor compression systems provide minimal gains over standard equipment. This is not true for evaporative cooling technologies. They improve their efficiency as the outdoor air temperature rises, reducing both overall energy consumption and peak electrical demand. Evaporative cooling has been used for years with varying degrees of success. When they hear the term evaporative cooling, some people think of leaky swamp coolers. But evaporative cooling has successfully been used for decades in large chiller plants. After years of technology development, similar strategies have been created for smaller scale application on commercial buildings.
You know, and the skepticism that's always come about, I've been in the business since 1996. I've been licensed. I've been in the business since 1989. And it was in the 90s, early 90s, where we did see in the commercial, we saw something close to this, very similar. It wasn't the cell deck pads, it was the aspen straw type pads. And those, what happened, it would just crumble, it would disintegrate and just kind of fall apart after a year or two. And all you'd have is water, because there's no material there, water's just pouring out. So times have changed from then. You know, technology's gotten a lot better, and so has materials. And now we have, this has been out a few years now, the cell deck pads, the material that it's made of, it doesn't fall apart, it doesn't disintegrate, it just crumbles into pieces.
Numerous modern evaporative technologies have proven effective through third-party testing, and customers are reaping the energy savings they deliver. One such third-party testing facility is the UC Davis Western Cooling Efficiency Center, or WCEC, the makers of this video. The WCEC researches, develops, and demonstrates technologies, including evaporative cooling technologies, that address both overall energy consumption and peak demand. A variety of evaporative cooling strategies exist for commercial buildings, and they can be categorized into two broad groups: condenser air pre-coolers and ventilation air coolers. This video will explain one evaporative cooling product called DualCool, which combines both strategies. DualCool is designed as a retrofit for existing commercial rooftop air conditioners. DualCool uses evaporative cooling in two different ways, hence the name DualCool. Number one, it improves the efficiency of the vapor compression cycle, and 2, it reduces the ventilation cooling load. Let's explain that a little further. An air conditioner cools air inside a building by blowing air across a cold coil that contains a refrigerant. When ventilation is required, air from outside is mixed in with air being recirculated within the building. The heat from the air is transferred to the refrigerant. A compressor pumps the refrigerant to another component inside the air conditioner, called the condenser, where the heat collected from the building is exhausted, or rejected, outdoors. In short, an air conditioner moves heat from inside the building to outside the building. The hotter it gets outside, the harder the compressor has to work to reject the heat. When this happens, the compressor uses more electricity and the performance of the air conditioner is reduced. One of the ways DualCool saves energy is by cooling the air around the condenser, making it easier to reject the heat to the outside. DualCool cools the air around the condenser by pumping water over a rigid evaporative media. As the warm outdoor air passes through the media, the heat of the airstream evaporates the water into the air, cooling both the air and water exiting the media. The chilled air then arrives at the condenser coil, allowing the air conditioner to operate more efficiently, as if the outdoor temperature were lower. In the process, DualCool also generates cold water. This water circulates through a water-to-air heat exchanger, located in the ventilation airstream, which cools ventilation air before it enters the rooftop unit. The water is then returned to the evaporative media on the condenser side of the DualCool. In this way, DualCool simultaneously reduces the cooling load and improves the efficiency of the vapor compression cycle. Although evaporation is used to provide these benefits, no humidity is added to the air that then enters the building. The evaporated water is rejected outdoors by the condenser fan. DualCool is effective for a range of climates and applications, but the energy savings achieved increases as outdoor temperature increases and humidity decreases. So, DualCool is particularly well suited for hot, dry climates.
The reason we went with DualCool is that the owner wanted to improve their HVAC system, and the local utility had some incentives in place to encourage them to install innovative products. And the utility had an interest in testing evaporative products, and we gave a couple of options to the owner, and they liked DualCool because it allowed them to use a compressor still and have as much cooling as they wanted without adding moisture to the ventilation air. The DualCool system with the new package unit made it so that there was essentially no change in the comfort inside the building, or it would improve it. But we didn't have to worry about matching capacity or ventilation, because pretty much we could just pick a rooftop unit that was similar to the old one and then add the DualCool and just get extra savings, but still hit the capacity that we wanted.
Most of the western United States is suitable for DualCool. The manufacturer, Integrated Comfort Incorporated, or ICI, conducts detailed site surveys to confirm that each potential site is a good candidate for their product. Independent laboratory and field evaluations of DualCool have confirmed that it can reduce electricity use by 40% during hours of peak electrical demand. Of course, total energy savings depends on the specific conditions in which the technology is applied. As with any efficient cooling strategy, greater savings are possible in buildings with larger cooling loads and longer operating schedules. Whereas some efficient cooling strategies are designed to replace rooftop air conditioners, DualCool is designed to retrofit or add on to existing systems. As long as the existing systems are in relatively good condition, DualCool can reduce energy use by harnessing the power of evaporative cooling, and equipment replacement is unnecessary. DualCool customers include several large stores with locations in California, Nevada, Utah, Arizona, New Mexico, and Texas. As of 2017, roughly 1,800 DualCool units were installed and operating throughout the western U.S., with over 700 units in California alone. Like any HVAC equipment, DualCool requires ongoing maintenance to ensure it continues to function reliably. As an assurance, the manufacturer provides proactive seasonal maintenance for every DualCool system for 5 years. Maintenance is simple but important and usually includes 3 site visits per year: a spring startup visit, a midsummer check to make sure the unit is working properly, and a fall shutdown visit to prepare the unit for the off-season. As with any new technology, it is important to have a foundation of service professionals that are familiar with maintenance and system operations when problems inevitably arise. DualCool maintains a network of trained technicians throughout California and the western U.S. These professionals make regularly scheduled service calls and are available if problems arise.
So initially started, I had some doubts. I'm not gonna lie, I had some concerns. Mainly was the water. I knew of the cell deck pads because we installed Master Cool on residential and commercial, and they had these pads, so I knew that these were okay, these were good. But the way that it worked and how it worked, I felt that there was a lot more maintenance that would need to be involved. I'm surprised that it's not as much maintenance needed than I initially thought. I did have some people, just colleagues of mine, was saying it won't work, it won't work. Well, here it is 3 years later, and it's working. And not only that, like I told them the maintenance of it. I said, dude, I take photos, and I said I have a little collection that I have, and I go, this is 1 year later. What are you talking about? There's little, little scruffs. That's it. Maintenance for us, it does take a little bit of time, and you do have to clean them according to manufacturer's recommendations. But for the most part, it's not really difficult. all our tools and materials can fit in a backpack. We take up hoses and things like that, little high pressure systems, so it's not difficult for us to do that.
Energy efficiency can sometimes seem like a black box. Ambitious claims of energy savings are promised, but it can be difficult to know how well a technology is actually performing. DualCool includes a web-based dashboard where customers can view HVAC system performance in real time. The tool can be set to send custom notifications and includes analytic features that allow for the measurement of energy savings. The DualCool dashboard provides transparency into how well the technology is working. Evaporative cooling technologies of today are designed to minimize water use and deal with a range of water supplies with varying quality. The money saved from reduced electricity consumption and peak demand can be used to offset the cost of the water used, which is typically only 3 to 15% of the electricity savings.
And we also measured the water usage. The water usage was reasonable. And we looked at the cost of water and the cost of the energy savings, and it came out that it was worthwhile.
The cost of a DualCool installation varies with the project details, including the number and size of the units. Current pricing in 2017 was estimated at $33,000 for a rooftop with 5 10-ton rooftop air conditioners. The manufacturer estimates that a retail space that operates 16 hours a day, 7 days a week, might reasonably expect to recover the project costs in about 5 years. Expected payback periods decrease as projects increase in size, since there are economies of scale for larger systems and more units. Utility incentives may also reduce the cost to the customer and expected payback period. Of course, actual payback will vary in each circumstance, but customers who have installed the DualCool report payback periods within 5 years. DualCool is sold directly to customers through the manufacturer, Integrated Comfort, and select distributors. Initial sales inquiries can be made through their website, www.icidualcool.com/sales/. DualCool units are built in Integrated Comfort's warehouse in Sacramento, California, and installed by affiliated technicians who receive in-depth training from the manufacturer. Technicians are convened each year to share the best practices and learn about any modifications to the product. Integrated Comfort maintains a close relationship with their approved technicians, so customers can trust that installers are reputable and experienced.
After doing a couple and operation, doing some measurements, checking the water levels, the temperature of water, the air, and I did on one store, I went on my own and I took air reading temperatures before and after, see how many temperature difference that is, the amps before and after. I did my own on one little unit just to kind of get an idea, and it did work at that point, and it's the best efficient, cost-effective way to do something that you have in an existing building.